I'll click the record button. That looks like it's working. Cool. Okay, so I made a slideshow, and then I'm gonna do some live coding after the slideshow. That's kind of the setup here. So let me just share my screen. Ideally, I'd probably, do like a little lecture, then do some demos, then go back to some lecture to talk about more advanced stuff, then go back to live coding to show it off, then go back to, but that just sounded too hard. I don't know. So I just am going to go through the whole slideshow, and then I'm just going to go through a few live coding examples instead of going back and forth. All right, let me share my screen now. All right, can everybody see the slideshow here? All right, cool. So this is the intro to testing talk. And I'm just going to get right into it. We'll start with why, because I think there's a few reasons why you should that you might not think of at first. I think the one everybody thinks of is it exposes bugs. You should write tests because it exposes bugs, but that's actually the least important reason to write tests, in my opinion. I think the main reasons you want to write tests is because it can improve the quality of your code by forcing you to structure your code in a way that makes things kind of more maintainable later. That not even because of the test, but just to write the test, you have to make your code kind of modular to make it easily testable. And then in so doing, you have more modular code, which is good in general. That one's kind of hard to understand until you've seen it in action. But trust me on that one. That's like the main reason to write tests. Maybe this number 2 bullet point is pretty big deal. When you have tests, you can refactor your older code, and you can be confident in doing that. You don't have to worry if you're breaking behavior, because when you do break behavior, the test will reveal that. And so the refactoring becomes like a joy. Basically, you're like, I'm going to clean this code up, make it nicer. So I'm going to refactor it. And because there's all these tests, as long as the tests pass, you did a successful refactor, and the behavior should be the same theoretically. When you don't have tests, I don't know about you guys, but if you've ever worked on a large code base that doesn't have tests, no one wants to refactor anything because everyone's scared they're going to break something, especially when it's a big project with lots of people working on it. No one really understands the whole thing. So whenever you're working on something, you're worried that you might break someone else's thing. So just no one ever refactors anything. And then what happens is the code quality just gets worse and worse over time because no one ever cleans anything up. So over time, that can be a huge problem. So if you have tests, it enables you and your team to refactor older code without worrying about breaking stuff. So then you're just going to be more likely to actually clean things up. So that's a huge reason for writing tests. Okay, another good reason is it provides documentation. If you think about it, because your tests are basically saying, I'm expecting the code to do this, and then it's testing that, you're getting a benefit of documentation because someone can read the test and see, well, like, what is this, function, let's say, what is this function supposed to do? Let me look at the test. The test will tell me what it's supposed to do. And that's usually a more up-to-date and accurate form of documentation than whatever's written down in the comments or a README file or even a website that has documentation. Usually that stuff can get out of date, or that stuff can just be wrong, whereas the tests are usually very accurate. So tests are a great documentation. If you're ever trying to understand what a code base does, if it has tests, just look there first and start kind of looking at how the tests work and what it's expecting out of the different components. And that's actually a good way to understand how a software system works. So if you're ever maybe working on an open source project or something, find the test file and just kind of look at the tests. Okay, so last bullet point is, why should you write tests? It exposes bugs. So yeah, that's the obvious one. But I think that some of those other things are maybe a bigger deal. But it's obviously a good thing to expose bugs. I mean, and that plays into the refactoring one, obviously. Okay, so that's the motivation. Let's move on here. So there's just some terminology you'll see if you read about testing. People talk about unit tests and integration tests, and then those last 3, functional, system, end-to-end. I see those words thrown around kind of interchangeably, I feel like. Let's go over what each one of these is. So A unit test is basically testing like the simplest possible thing you could be testing, like just a single, they call it a single unit in isolation. So that could be like a function. And you're just testing, if I give this function this input, it should, return this output. Maybe if it's a function that adds two numbers together, your test might be like, if I am trying to add 3 and 5, I'm expecting 8 to be the output. That would be a perfectly solid unit test. And that's what people mean when they say unit test. They just mean testing an individual piece in isolation. Okay, the next type, kind of the next level up from that, is an integration test, which kind of the name implies it's testing the integration of multiple units working together. So an example of that might be like clicking on a button sends a post request. So maybe you have a button component and that requires some module that deals with HTTP requests, and you want to make sure those two things are kind of plugged in correctly together, such that when you click on the button, that other module sends the HTTP request. So you're kind of testing that these things are integrated properly. The next level up, sometimes people call it functional, sometimes they call it system, sometimes they call it end-to-end tests. And this is like testing a complete feature from end to end. So for example, clicking on a button sends a post request to an API. The API endpoint handles the request successfully, writes to the database, and then you see on the front end some response, and that response is rendered on the front end, and it has the data that you wrote in the database, or something like that. Something that represents like a feature. That whole thing could be tested, and that would be an end-to-end test. So when you're writing tests, you're going to be doing all of these things, but sometimes it's useful to kind of break it down into these categories. But some people take this more seriously than others. I find that I just kind of write tests, and then some people are like, all my unit tests goes in this folder, and all my integration tests goes in this folder, and that could be helpful for different projects and different scales of things. But I wouldn't get too hung up on that kind of stuff. But just it's good to know this terminology, though. When you're communicating with other people, they're going to be saying these words. It's good to know what they mean by that. All right. So I'm going to give some tips. Like I said, we're going to do a live demo after the slideshow where I'm going to show you how to actually write tests and stuff. But let me just kind of run through some things that I think will be good tips to know. When you're getting started, I think integration tests are kind of like where you should probably start. Because they're easier to implement sometimes than unit tests and end-to-end tests, because with unit tests, you often have to structure your code a certain way to be able to unit test everything. And that goes back to what I was talking about earlier, where when you write tests, you have to structure your code a certain way, which improves the modularity. So that's a good thing. But at first, when you get started, it's like hard to do that. So you can kind of just skip writing unit tests for certain modules and just write integration tests for them, and you'll have an easier time. And I think it provides a pretty big benefit still, because it still gives you that benefit of refactoring confidence. But if you want that effect on the code quality, you really want that like modularity effect, you have to kind of force yourself to really break everything down into units and really unit test everything. So yeah, I kind of talked about that already. I don't know if I have anything else to say about that. Let me just read my bullet points here. Right, okay, so if your code isn't modular enough, just to expand on this a little more, and you're trying to unit test it, but your code's not very modular, you won't really have a way to unit test it. There's just no way to do it. You kind of, by testing your module, it's kind of an integration test, because your module is so coupled with other things that the only way to even test it at all is to kind of like accidentally be testing an integration of things. And if you really force yourself to break things out really well and plug them together in a really composable way, you kind of, you improve your architecture, but you also made it possible to unit test each piece. Okay, and then some people get really obsessed with code coverage metrics, and I think my tip on that is just don't even worry about that. I usually don't even have code coverage on my stuff. I just know if my stuff's well tested or not, because I just check my gut, and it's like, at any given time, do I feel confident in refactoring my code? And if the answer is no, then I probably don't have enough tests. And if the answer is yeah, and I totally feel good about refactoring and I'll do it, whenever I want to clean things up, and my tests are making that easy for me, then I know I have enough tests. So I don't really care what the like percentage of like lines covered under test is. Some people try to get as close to 100% as possible, but I think there's seriously diminishing returns with that. And I think just kind of feel it out. That's my advice for that. Okay. One more tip. Don't test implementation details like like let's say we're testing like the add function, add two numbers together. uh, just test the input and the output. Don't try to like somehow test like how it's adding the two numbers. Just test the interface. Okay. If you can test the interface but like ignore the implementation, that allows you to change the implementation later and your test will still work because you just tested the interface. And that kind of gives you the benefits of testing that we had before, but without that coupling. You don't want your tests to be like coupled to your code such that if you change your code, you like have to change your tests, because that's like a maintainability problem. You always want to avoid coupling if possible. So your tests can actually introduce coupling, and you want to avoid that. So test the interface, not the implementation. Okay, moving on. Some limitations of testing. Just be aware that just because you have tests doesn't mean that you're covering all of the possible bugs. I mean, you're only going to expose the errors for the particular test case you write. So for example, in the add function I talked about, adding two numbers together, if you say like add 3 and 5 should be 8, that's only one possible of all the combinations of inputs and outputs. That's just one. So you have to write multiple tests, but it's just ridiculous to try to write all the combinations. I mean, that's not really realistic. So there's always going to be holes. There's always going to be edge cases that your tests probably don't cover. So a good, thing to keep in mind is maybe purposely try to test edge cases. Ask yourself like, does this handle, like 0 correctly? Does this handle negative numbers correctly? Does this handle giant numbers correctly? Just think of like different types of inputs and just try to think of the edge cases, but don't try to just test every possible input. Just accept that there's going to be holes. Your testing is only going to, it's only testing what you tell it to test. Okay. And then I talked about this bullet point here. If you're testing, especially if it's not done well, but also if you just do too much of it, it can be coupled with your code in a way, and that can actually be a problem. Some people even avoid writing too many unit tests because they think it leads to coupling. So they think it's like a bad practice. Most people say it's not a bad practice because it shouldn't lead to coupling if you do it correctly. So some people say if you do it well, there's no coupling between tests and code. Other people say that inevitably there's going to be some coupling at some point. So I think, I'm not sure. I kind of feel like if you do it well, you can avoid it. But even if there's a little bit of coupling, the benefits outweigh the cons usually. So just don't overdo it. And then you should be, gaining a huge advantage. Okay, classic quote. I just have to throw it in there because it's a famous quote by a famous computer scientist. So program testing can be used to show the presence of bugs, but never to show their absence. So I like this. It makes a great point. It's just because your code has tested, that doesn't mean it like you're not proving anything about how it doesn't have bugs. A test can only ever expose a particular bug, but it can never like make some kind of guarantee that there's no bugs. So tests can never show the absence of bugs. It can only expose the presence of a bug. So, it's anyway, the guy who said this was an advocate for what's called formal methods, which is more about proving the absence of bugs. So how do you prove the absence of bugs? Well, testing is not going to do it. You have to get pretty advanced with some mathematical techniques, do actual proofs, formal proofs, and then there's tools, static analysis tools can help you do this as well. We're not going to get into that stuff, but I just thought I'd mention that because this is kind of like a whole field of computer science is based on proving the absence, and tests are not that. It's a different thing. Okay. Lastly, let's just quickly talk about test-driven development. Then we're going to get onto the live demo here in a second. Okay, you're going to hear this term a lot. It's kind of a buzzword. It just means basically you write tests first, then you write the code, instead of writing code and then writing tests for your code. It just flips it around. So most people kind of naturally would want to write the code first and then write a test for it. But the test-driven development people say you should actually write the test first, then write the code. And they give some laws, the 3 laws of TDD. So don't write any production code until you've first written a failing test. So it makes sense, right? The test is going to be failing when you first write it because you haven't even written the code yet. So you write a test, it's failing. Your test is not passing. Then you write just enough code to make your test pass, but don't write any more code. Like stop there, just make it pass. And then you kind of add to it by writing another test, like expanding your test and then making just that pass. Don't write any more code. Then you kind of write just enough test code to have a new failing test. Anyway, it's kind of like an iterative process. And you kind of just keep going where you write some test code, implement that to make the test pass, write some more test code. So now you have a failing test, implement that to make that pass. And you just kind of like go in a circle. Okay, so why do that? Well, it's kind of just like a way to, if that's just like how you do your work, it's just like a habit, you just do things that way, you're kind of like automatically going to have a pretty rigorous testing setup with a lot of code coverage. And it's also going to force you to do that whole like structure your code in a modular way such that it's easy to test. It's going to like force you to do that because you're going to be sitting there writing a test. You haven't even written your code yet. And you're thinking like, how can I even test this code? I haven't even written it yet. How do I even test it? And then you'll write a test, and the way you'll write it in a way that's like, it kind of expected a certain amount of modularity out of what you're about to implement. So then when you go and implement it, you kind of have to do it that way now because you just wrote some unit tests. So it's actually pretty cool. But I should point out there have been empirical studies. So empirical software engineering analyzes repositories and projects, and using statistical methods can determine things like, does this technique lead to reduced defects in the product or whatever. It's a pretty rigorous field in itself. And there has been empirical research that shows that practicing test-driven development doesn't really produce any benefits over just writing your tests afterwards. So if you write your tests first to do it TDD style versus writing your test second, we're controlling for like the control variable here is like writing tests. So assuming you're writing the same amount of tests, writing it first versus second does not show any benefit in the empirical literature. So keep that in mind. So some people promote TDD as some magical thing, like, if you do this, your code's just magically better. It's not true. It's not actually better. It's more of, I think, more of a subjective experience thing where it seems helpful to do it that way. The end result's not going to be different. At least it shouldn't be. All right. I think that's enough. Let's do the live coding thing. Quick note about the live coding demo. I could make a whole talk on like a specific test framework. There's a whole bunch of different test frameworks that help you write tests. Just like React helps you write JavaScript, or Django helps you write, Python web servers. There are test frameworks that help you write tests, but this is not a talk about a specific test framework because I wanted to do something very general. So I'm going to focus on the fundamentals of testing. So just like how to write a unit test, and how, some tips for how to structure things to be modular, that kind of stuff that I talked about. And then you can apply this to any language, any test framework, etc. So you'll have to probably learn, how to use the test framework in whatever language and environment you're using. I mean, there's even special frameworks that are just built specifically for React or Angular or whatever it is. And you might want to look into those. But today we're just going to do some simple Python tests, and we're not going to talk about the testing framework very much. Okay, that is all. So now let me exit out of this, and I'm going to just open up I have an empty folder here. I'm just going to make a file and I'm going to write some tests and we're just going to talk about testing. So let's, I'll make a new file called test examples, I guess, .py. I'll open it in Visual Studio Code because that's what people here at Code Guild are used to these days, at least. Okay, so I'm going to use a testing framework called PyTest, but like I said, that shouldn't really matter. You'll do whatever you have to do to write your test in your test framework, but the principles I'm showing here should work. Okay, we talked about the good old add function, so let's just use add as an example. So let's say I wanted a function that adds two numbers together, and I think that should do it. And I want to test it. So I could do the test in another file, but to make this presentation easier, I think it makes sense to write the test here. So I'm going to write a function called test add. So PyTest, the framework I'm using, actually expects my tests to start with the word test. So I actually have to do that for this test framework to work. Other frameworks are different. Okay, so I'm going to assert, and this is how you test things with PyTest. And all test frameworks have some way of asserting things. The syntax will be different. Maybe it's a function that you call. In this case, it looks like some kind of a special keyword. You're just asserting that something equals something else in this case. So I'm asserting that add, 3 and 4 equals 7. And if I run this test, I'm hoping it will pass because I'm hoping my function, implemented that correctly. So let's run it. To run it, I just run PyTest, and it says 1 passed. Okay, so it gives me some info, 1 passed. I can also run it with the -v argument, and it will tell me like the specific test that passed. Test add passed. All right, well, let's write a failing test now to see what that looks like. So maybe I implemented my function incorrectly. So I'm just going to mess this up. I'm going to say x plus x. So maybe that's just a typo. Maybe I was writing the code and I just messed up. So for example, if I would have tested 3 plus 3, this would actually, 3 plus 3 equals 6. This would have actually passed, even though my code has a bug in it, right? So it's important that you don't just test one thing. It's important I don't just test this. I need to look for edge cases. So maybe one case is that the numbers are the same, but another case would be the numbers are different. So you definitely want to have multiple different cases. So 2 and 3 are different. So that should provide a slightly different test. Let's see if I still pass. Okay, I have a failing test. So it says 1 failed. So I know that other one is passing still, but it gives me some information. Assert 4 equals 5. So I knew that I had add 2 and 3 right here. So for some reason, this is 4 because I'm seeing here, the error says I'm basically asserting that 4 was equal to 5, but this should have been 5. So what's going on? Then I would have looked at my code and I would have said, oh, I had a mistake here. This should be x plus y. So now I fixed my code. Let's rerun the tests. Boom. All my tests are passing. That's basically it. But how do you do this on more complicated projects is kind of the hard part. But what I just showed you here is kind of everything you need to know in terms of the fundamentals. But let's get into some slightly more advanced examples. I'll kind of leave this up here, and I think it'll be easier just to work in one file, like I said. Let's say you want to do something like this. You have a function called hello that prints hello with an exclamation. And I want to test that my hello function prints hello. Okay, so this is kind of an interesting case because I have a function here that I can't just assert its output the way I could with add. I can't just say this. I can't say you might think you can do that, but that's not going to work because my function doesn't return the string hello. My function does not do this. I mean, it's not even supposed to do that. So I don't really want to write this test because that's not what it's supposed to do. My function prints hello. That's totally different than returning hello. So this is not going to work. So how do I do that? Do you want to have any ideas? It's kind of tricky. And this kind of gets at the problem of trying to write tests for like real applications, because a real application isn't necessarily just a bunch of functions that input and output stuff. They're functions that have side effects on the world. Now, you might have heard of the whole functional programming thing, in which case you avoid having side effects in the world. And maybe now you're seeing why that's a good idea.
Having side effects in the world. And maybe now you're seeing why that's a good idea.
Mm-hmm.
What's up?
Someone unmuted, but I took care of it.
Okay. I didn't know if that was a question or a suggestion for how to handle this problem. So anyway, consider that having side effects makes our code harder to test, essentially. And that's why the functional programming people try to avoid it, because the code becomes really easy to test if all your code, for the most part, is just functions taking inputs and returning outputs. All right, but this isn't a talk on functional programming, so I'm not going to go into how to do this necessarily too deep with that kind of stuff. I'm just going to show you how you can get around this with a technique, a testing technique called mocking, where we can mock the print function such that it's kind of more under our control what it does, and then we can call our code with our mocked print function, and then we can test that the print function was called with the correct arguments. So basically what we are expecting hello to do is call print with the string hello. That's what our hello function does. It calls print with the string hello. Now, if we just structured this to be slightly more modular and correct with how it handles its dependencies, we can actually test that. We can test that hello calls print with the string hello. All we have to do, but here's where I talked about this in the slides, we have to restructure our code to be slightly different to enable us to write the tests. So I'm going to have to change this a little bit. What's going to have to happen is hello is going to have to take in a function that prints stuff, and then it can call that function. And now in our real code, we can pass in the real print function, and then it will actually print stuff. But in our test code, we can print in, or we can pass in a made up print function that all it does is it performs an assertion for us that, the right thing got passed to it, basically. So for example, I can say, I can have like a test print function here, or like a mocked print. And it takes in some string s, let's say, and I just want to assert that s is equal to hello. And that's basically what I want to have happen. So then in my test hello function, I can call hello and I can pass in, or not, I don't want to pass in the real print function. I want to pass in my mocked print. And let's see if that works. There's some other techniques we can do if that doesn't work, but it does work. Okay, great. So yeah, all the tests are passing. Test hello passed. All right, so now you might be wondering, okay, how do I do this in the real world if I actually want to call hello for real? I don't want to pass in this fake print function. Well, so in the real world, you would just, whenever you want to call this in your actual code, wherever you call hello for real, you would just pass in like the built-in print function. That's all it would be. And then it would execute correctly, because when it calls print here, this variable will refer to the actual print function, the correct print function. However, in our test, we're not passing in the print function. We're passing in our mocked print function. We're not passing in the real print function. So we're not dealing with actual side effects in the world anymore. We're just testing that hello does what it's supposed to do, which is hello is supposed to call the print function. So this is basically called dependency injection. It's like a pattern of software development that is useful. You're injecting the dependency of the function. So hello depends on print. Instead of just calling it like this, where the dependency is, it's kind of just fixed and unchangeable. If we pass in the dependency like this, now we have total control of what print function it calls, and we can test it now. Okay, and now let's think about what I said earlier. If you want to test your code, you have to structure it a certain way to make it testable. So you're gonna have to redo it a little bit, make it more modular, make it more flexible. That's what we just did, so now we can test it. And remember I said that a benefit of testing is your code actually improves by being more flexible and modular just by structuring it differently. So how did it improve? We have to test, but some of you might be thinking, isn't it worse now because it's kind of annoying to have to pass in print? Like, how is that an improvement? Well, what if we wanted print to do something different in different contexts? Our code now is flexible. Before, hello always did the same thing. It printed hello, but now we can call hello in different contexts and pass in different print functions that do different things, like maybe write to a file instead of just print to the console. Or maybe it sends some network request. Maybe it writes to a database. Whatever it does, it's basically like directing output wherever we want it to go. I mean, it could do anything. Or in the case of testing, the print function can make an assertion. It can do anything. Whereas before, it was very, very fixed, and it always did one thing, which is print to the console. So now let's talk about another example where that could be a huge deal. So let's say I had a function like send payment, and then the dollar amount. Okay, and I want to test this, but I don't want to actually let's say I have like a PayPal API, PayPal API send payment. So I'm like requiring a library that actually sends a real dollar amount to someone using the PayPal API. And I pass in the dollars to that. And that's what my send payment function does. It calls this PayPal API. Okay, now I want to write a test for my send payment function. I mean, that's great. It's good to test things. We should write tests, right? So let's test send. Payment. So I want to make an assertion about what it does or something. I mean, maybe it also returns something, like maybe it because maybe this returns like a success or failure or something, like I don't know, I'll just say like response. And then maybe I want to return that response. Maybe I would have done something with it first, whatever. And maybe I want to make an assertion about the response. So I call send payment. Maybe I pass in $100. And I want to assert that, the response it returned was like success or something, or 200 if it's a response code, maybe it's something like this. Some kind of like HTTP response thing or something. All right, well, does anyone see a problem with writing a test like this? What's going to happen every single time I run this test? Someone's going to get sent $100. So what did we do for our hello function? We injected the dependency such that we could control what it does. So, this PayPal API, that's something I import. Maybe I downloaded it from the internet, someone else's code that implements the PayPal API stuff. But for the sake of my test, I don't want to actually use this. I want to use a mocked version that doesn't actually do anything. Here's what I can do. I can say the dollar amount, but also the, send payment takes in this function as an argument. Okay. Just like hello could take in print as an argument, send payment could take in the PayPal API as an argument. Okay, now what my test can do is I can make a mocked PayPal API that it's expecting a dollar amount, and I don't even have to do anything with that. I can just return whatever I want. I can just pretend it's a success. I can just return success, basically. That's the success message. I could also return other things. I could return like a 500 error. And then I could test that my code like deals with that error correctly. So I might actually want to do this. So I might call this like mocked PayPal API error, and I might actually want to use this. And then I might have another test case though, where I just have one that returns success. So let's see for this example, if I call send payment and I pass in the mocked PayPal API, the one that's returns success, I'm expecting it, I'm expecting my send payment function to, return a success. So let's run that. Hopefully that passes. It passes. And no one was sent $100. That never happened. And then in my real app, just like in my real app that uses hello, I can pass in the real print function. Well, in my real code, instead of my test file, in my actual code, I can call send payment, and I can pass in, the real PayPal API object, which is something I probably would import, install it with pip or something, so I'd probably have like from, PayPal import, send payment, or I guess I called it real PayPal API. Because my function is called send payment. So I might have something that looks like this in the real code, and then I pass that in as the dependency. So now it's using the real version. So this isn't my test code. This is my real code here. Okay, so I'm going to get rid of that. Let me make sure all my tests still pass. Okay. All right, that's basically everything I wanted to show. So whenever you learn a testing framework, there's going to be a ton of bells and whistles to it, but the main thing it's going to have is some way of asserting that something is true. So if the assertion's false, your test fails. If the assertion's true, your test passes. So if you're doing React and you're using some React testing library, it's going to have some way of asserting. It's just going to look different, and it's going to have a bunch of other bells and whistles, like I said. But the principles I showed you here will get you pretty far. I mean, you can write most of your tests just by doing simple, double equals style assertions, and then using mocked functions and mocked objects as well. You can mock a whole object. Doesn't just have to be for a function, but you can mock anything to use the dependency injection pattern, which enables you to test your code without relying on the behavior of some, other function that, you don't want to have to actually run. And that allows you to run a proper unit test. Because remember, a unit test, you're trying to test something in isolation. You're not necessarily trying to test the real end-to-end behavior of your deployed system. You're trying to just test some piece in isolation. So then you're going to have to inject your dependencies in and mock them out. Okay, there's other ways though of dealing with it without mocking. For example, we could have just, for hello, for example, we could have just returned the string instead of printed it, and then something down the line could have printed it. And that would have been a way of avoiding mocking the print function. And then we would have had something that was easier to test. So, sometimes when you're mocking, if you're mocking a lot, you might want to ask yourself, like, do I have to actually be doing this? Could I just be like writing functions that just return stuff instead of print stuff? And then something later will print stuff. A lot of times that's going to make it easier to test. So basically, like, my advice is, like, if you can avoid mocking by having simpler things that just return stuff, do that when you can. And then in certain scenarios, like, for example, the PayPal API, you want to test that your code that's using this kind of uses it correctly, but you don't want to actually use it for real in your test. In that case, you're going to probably have to mock it. So sometimes you have to mock. Other times, you can probably just maybe rethink how you're doing things and avoid side effects and just return stuff. And then something later will perform the side effect. So that thing will have to be, tested in a different way. That thing might have to be tested with mocks. But if you can put it off to like some other module that performs the side effects, what you can do is you can structure your app where, like, most of it, there's no side effects. Everything's easy to test. And then some outer modules perform side effects. So like the core is just pure functions. The outer shell performs side effects. And then you can test that core super easily without mocking anything. Everything can be easily tested. And then there's just those things on the very edge perform real side effects. All right. So I'm almost done because I got to go teach a class at 6 o'clock. But I do have one thing I want to show you guys. If you just want to see an example of like real testing, like more tests for a JavaScript app, I wrote this fun little animation thing in a JavaScript app, and I wrote tests for it, so you can see all the tests. But let me show you what it looks like if you just wanted to see like slightly more realistic situation. So this was when this was closer to when coronavirus first happened. This was like, you know, several months ago now, probably. It tests these little entities infecting each other. So like, for example, if we have a bunch of green is healthy and the red is infected, every time one runs into another one, it turns it red. So over time, they become more and more red until it's all red. But then you can also add medics, which will heal them. Every time you adjust the slider, it restarts. So the medics will heal the red ones and turn them green. Anyway, it's a fun little app. I show it to you though because I wrote extensive tests. I practiced TDD the whole time pretty much. So there's tons of tests if you want to see what that looks like. Let's look at, and there's mocking involved. I mean, because I had to for certain things in certain instances. You know, let's test the movement of the entities. So apparently when you call the move function, it should return a new array with updated positions. So there's some array of positions, and when you call move, the positions should update. This kind of gets at testing being a form of documentation, like I mentioned. I probably did not write any comments in this code, but you can look at the tests, and the tests are like comments, right? Medics should move, or medics should not move if there are not infected actors present. So if there's no infected entities, the medics shouldn't move. Apparently that was a decision I made. So if you're reading the code, but there's no test, you wouldn't necessarily know that that's supposed to happen. You might be like, why did the medics stop moving all of a sudden? Shouldn't they keep moving around randomly or something? Well, maybe, but if you look at my tests, apparently I was expecting them to stop moving. So that's some nice documentation. Now no one's going to be confused if that's a bug or not when they see that happen. There's other tests. So anyway, test perform documentation or provide documentation, something I mentioned earlier. Anyway, there's a bunch of stuff here. If you look at the code though, you'll find that I did that thing where I have a lot of pure stuff in the middle and then I perform more side effects on the outside, which are not tested, which is okay. So let's look at that. I think is there like a main file out here somewhere? It's probably index.js. All right, so here's the setup is basically like, you can notice that I require these modules like move. We looked at move a second ago. I require move, and here I'm injecting a dependency, okay? So I'm actually, because there's a lot of random stuff and it's kind of hard to test what random's gonna do. I mean, if your code like depends on random stuff, it's hard to test it because, like adding two numbers is easy to test because 1 + 1 is always 2. But like, what if it's like 1 plus a random number? How do you even test that? Well, you have to use dependency injection. You inject a random function of some kind that always returns what you expect it, so you can test it. So I had to do that. So you can see I dependency inject a random function here, and this is the actual code. So this random function here is like an actual random function that actually does random stuff. In the test code though, you'll see that I like make a mocked version that returns, not actually random stuff, but stuff that I can predict, which made it easier to test. So anyway, this might be an example that maybe will be helpful for you to look at, especially if you're more of a JavaScript person. Maybe look at this stuff. You'll see examples of, asserting things and dependency injection, and that was really all you would have needed to make a whole app with a lot of tests. So the basics will get you pretty far. You don't really need anything more than what I showed you today. But like I said, if you learn a modern testing framework, there's going to be a ton of bells and whistles, and you can go pretty deep in more advanced stuff. But yeah, start with the basics. All right, I gotta go teach my class at 6 o'clock, but I can answer questions for about 5 minutes. Does anyone have any questions for me?
Yeah, I had a question about the. Can you hear me all right?
Yep.
Okay. My internet cut out for a bit, so I missed the beginning of the testing actual aspect. Was that a Python module you were importing to do the assert functionality? You were talking about testing frameworks and stuff. I kind of missed out on that.
Yeah, I'll link to it in the Are you in the Slack? You want me to link to it in the Slack?
I'm actually not part of the Slack. I'm new to this group. I would
Okay,
love to
okay. Let
join,
me put it in the Zoom then.
though. Okay, beautiful. Thank
There's
you.
a thing called PyTest is what I was using.
Thank you. I appreciate it.
Yeah. Yeah, it makes it really easy. I like it.
I have
Here we
a
go.
question, Evan.
It's in the chat. Yeah, what's up?
So would all of those tests that you were writing the examples, would those all be considered unit tests? Or would the like injected dependency ones be like integration tests? Like what would be an example of an integration test?
Yeah, so all of them are unit tests. Because I injected the dependencies, I was able to test the functions in isolation because I injected the dependencies. If I was using the real dependencies and not injecting them, and then I was testing that, the actual thing that needed to happen in the real world, if I was testing if that actually happened, that would be more like an integration test or a system test. So for example, maybe I have like a staging environment for a website, and I wanted to like test that clicking on a button triggers like a PayPal API request, and I want to test that the PayPal service actually got the request. I mean, that would be an integration test if I like actually was hitting up the real API, for example.
Okay.
But yeah, in my example, I was just doing unit tests pretty much. Yeah.
Got it. Thanks.
Yeah. And then in terms of like a command line example of this, like if you had some way of actually reading the print output, and so you actually use the real print function, and then you somehow, tested that the text that was output from your program was the text you expected, that would probably be considered an integration test because you're like actually analyzing the actual output instead of just mocking something. Yeah. Any other questions?
I got one.
Yeah, what's up?
What would be a good way to practice this for those of us who've never really done much in the way of unit tests or tests of any kind?
Yeah, so I would definitely recommend like a TDD approach with a super simple program. And so write the test first, because if you try to write the tests afterward, you're gonna probably find that you don't know how to test it properly.
Mm-hmm.
And it's harder to like take something you already have and like make it testable. It's kind of easier to start with writing the test, and then now you have to write it in a testable way. And that being forced to do it that way, I think will like cause it to click more in terms of how you do it. But yeah, I mean, to get started, the simplest thing would be just, first make sure you just know how to call the assertion library that you're using, and then just test that some simple function like we did here, like adding two numbers together. Just test the output of that. If you input 5 and 5, you should get 10. Just write a few of those. But then you'll have to get a little more advanced. Now you should start testing something that actually performs output in like on the console, like print output, and you'll have to mock the print object or mock the input object. If you're getting input, you can mock input and print, and then you can control the whole thing. I don't know, but yeah, just basically force yourself to do it there's no way to like, kind of learn it without doing it. So you kind of have to get over that initial hump of just like forcing yourself to do it.
Is there anything that might have like a tutorial to follow? Or like,
I mean, I don't have like one off the top of my head, but yeah, I mean, of course there's a bunch of books and tutorials online, but
gotcha.
I don't know. I learned by just like mainly just doing it after having seen it. So I worked with a code base that had some tests, so then I could like refer to those, and then I like looked at how they did it, and then I kind of could figure out how I could do it for myself.
Cool.
So that's why I provided that JavaScript thing. Actually, let me link to that here.
Yeah.
I provided that because then you can kind of see how someone else did it for a real project, and that might help you.
Thank you. I would appreciate that. Yeah.
Yeah. Cool. Okay, I gotta go to my class, but thanks guys. Yeah, thanks for the questions too.
Thank you for teaching.
Yeah, right on. See you,
Thanks,
everybody.
Evan.
Nice meeting you.
Yeah, nice meeting you guys.